Check, check, check. Okay. God, this tripod sucks. And this floor sucks. Okay. As per usual, I'm just gonna double check. Nice. Okay. As per usual, I'm just gonna double check. Okay, so I believe in the last episode we left it here. We started printing this guy. It finished printing. We discovered some things. That's what I'll say. So here it is. So for one, okay. So I believe in the last episode. Sorry, give me 1 second. I've got the stream running in the background still, and it's very distracting. Okay. So what we've got, the patterns turned out really nice. I really like these. One side of the flat part turned out really good. The other side did not. The issue I'm having this weird, like, texturing issue. I think that's a result of my filament not being dry enough, which sucks because drying this filament is hard. And I'll get into kind of my ideas on that a little bit later. But the worst part is that these parts, which took me the longest to design, didn't print at all. I designed them to the minimal settings, and so I think the slicer just didn't pick it up or something. It shows it doing it in the slicer. Let me actually see if I can pull this up. Okay, I didn't save the printer file. Anyways, it shows it. Actually, let's just do this because I really want to try and understand what happened here, so somebody can tell me. That would be cool too. So if you could see that, we can move this over and slice the plate. Okay, so you can see, I guess now that I'm looking at it, it does look like it's just not printing those parts, and I should have been more careful about this. It just kind of left them blank. It looks, if I change the color of this material, nah, see, it shows that it's printing, right? Isn't that what that's showing? Right? Isn't that what that's showing? So there's layer 1. So I don't know what happened exactly. But it didn't print these parts. And unfortunately, those are the parts that I had most confidence results in it actually sounding good. That being said, the sound of this, I'll just throw this in here. The sound of this is real meh. You know what I mean? It's just like, and maybe if I hold it here and hit it hard. I actually haven't done like a real test of this, so in my opinion, this does have kind of a low-end cymbal sound, and we're also getting a little bit of this like sombrero warping thing happening. The bell turned out nice though. Listen to the bell. I mean, it doesn't sound that good, but it printed beautifully. So I gotta keep working on this design. Didn't seem like these features did anything, but they look so darn cool. I kind of want to maintain something like that in the final design, so I'm gonna keep messing around with that. But I want to move on to the Kalimba for a second, because I reprinted the body of the Kalimba, and that will hopefully give us some ideas for the cymbal, and I'll explain why. So this was the original Kalimba that we worked on the other day. Let me just take it apart, because I'm gonna have to take it apart anyways. Actually, I'll try and maintain the order here. I gotta reorient the camera, don't I? Still trying to figure out the best camera setup for this. It would be great if I could see everything, or if you could see everything while I'm doing this stuff. So I showed you what it's. I should have tried playing it here on this stream. I did try playing it on the last stream, so if you want a reference, you can hear that. But basically, it sounded bad. It didn't sound like anything good. I added this piece of wood, hopefully trying to just see if rigidity will help, and it kind of did. So that's good news. Oh, these screws do not want to come out. There we go. Okay, so just based on the acoustics of this part alone, this is PLA. I was hoping to make it work out of PLA, because obviously this is a pretty big part, uses quite a bit of material, but you know, it has resonance there for sure, but it's quite low. But worst of all, it's relatively flexible, which is a bad thing. Because what happened is, when I tightened the tines on there, especially the middle ones, sunk in, and then when you plucked it, it would vibrate all the other tines. Because I think basically this flexible surface was just like, absorbing a lot of the vibrations and then also sending it back into the bridge. So we reprinted this out of PPS-CF. I once again had an issue with this surface finish. And again, I'm chalking that up to not dry filament. I'm going to mess around with the settings a bit more, see if that makes a difference. There, you can really see it. But luckily, this is on the inside, so the actual finish of the part is really nice. I really like the way this filament looks. But listen to it. So this is the original. And this is the PPS-CF. cool for a 3D printed part. So I want to assemble this. I want to assemble this and see. But the reason I'm thinking about the cymbal is the fact that this thing, this body of a kalimba, doesn't sound like a cymbal, but the high end on this is relatively significant. The resonance, relatively significant. Depending on where you hit it. I haven't even tried hitting it with it. That sounds crazy. So it got me thinking, like, the reason this sounds so good is because it is thin-walled. It's only 2 millimeters thick. But the actual geometry of it is allowing these thin walls to remain a lot more rigid than something like this. And this is actually thicker, but you can see how much bend there is because these are just flat parts versus the bell, which is extremely solid. There's nothing going on there. And so what's happening is this is able to resonate at much lower frequencies when we're aiming for high frequencies. I kind of want both. I kind of want a little bit of this like lower end wobble sound, but I also want the high end sound. So I'm thinking I need to change the geometry. And when you think about a regular cymbal, this part isn't flat. This part actually also curves. So I'm going to try a couple things. I'm probably going to reprint a similar design to this and throw it in a kiln or something and over a mold and see if I can let it deform into that shape. But there's some issues with that, and you know, I'll elaborate on that when I actually try it. But that's one way. The other thing is actually printing a different geometry that has sort of this rigidity built right in. The reason I didn't do that with this is obviously because if I printed like a shallow little slope on this, the bell works because it's you know, it's smaller, and because it's a dome, it kind of supports itself, and it's quite a significant curve on there. But with the edge, or with the outer part of the cymbal, that dome would just not be enough, and so we would have like these crazy overhangs, you know, like close to a 180. It would be like 170 degrees or whatever. So I just don't think it's going to print properly. We could try it, but I think I might have to like kind of rethink the geometry of a cymbal that needs to be printed. And so we're going to try some stuff out, and obviously like doing supports. And with this printer, it's a 2-nozzle printer, so I could theoretically do supports out of a different material. The problem is this material prints so hot, and I think it's just going to melt right into the supports. I could try it though, and that's, you know, something I want to experiment with anyway, so we might explore that. But I really think I could just, you know, kind of abandon the typical cymbal design and try and make a new design. So a new design that's kind of purpose built for 3D printing. But let's put a pause on that for now. We're going to come back to the cymbal later. Let's play with this. So the other thing I did, I changed this design a little bit. I added this rib right where the bridge is. And basically, I just want to add some extra stiffness without adding too much material because I still want it to resonate a lot. But anyways, without further ado, let's start designing this. I'm going to see if I can get this closer. Oh. This is my first time trying this camera setup, and I'm not loving it. And I'm going to close out the computer screen so that we can just have a nice big screen here. Beauty. Okay. My OCD is driving me a little crazy here. I kind of want to center this. Okay, that looks pretty good. So, let's do it. Let's throw... I made the holes for the screws bigger as well. It's one additional design feature. And that is now significantly easier to do. I'm going to try this with one tine first, because we may as well. Right. Let's do the biggest one just for funsies. It's this one here. And I just want to see where... Okay, yeah. So the new spine piece is like right there. Or not a spine, I guess it's more of like a rib. Okay, and then we'll throw this guy on. I think I'm gonna have to reprint these little bridge pieces anyways because I need it to tilt upwards. This is way too close to the surface of the actual Kalimba body. Okay. I want to tighten that. Ooh, yeah, see, this is more of the action I'm looking for. So when we tighten this one, this tip actually comes up. So you can kind of see it's actually aiming up. Whereas before, because this was compressing the actual body, this ended up curving downwards and like right into the surface of there, so that sucked. Anyways, with one, this is interesting. Why is this interesting? I'm actually feeling a little bit of air coming out of this hole. I'm going to put my headphones on so I can put this up to a mic and listen to this. Okay, it's really low. It's like so low. But I think it's working way better. So let's try and shrink this. And actually, I'm going to try just doing... No, let's just try and shrinking it first. I also want to print a single piece bridge because this is kind of like two-piece bridge. Is really annoying to adjust. And I'm going to print one that locks into the screws there. But anyways, that's just more for ease of use. Okay. That's quite nice. Now I'm curious if playing it this way. That's a decent tone. I think that sounds quite good. You know? That sounds so much better than when it was the PLA one. Okay, but now let's try this with... Let's just do all the tines. You know? You know what I mean? Let's just do them all. And actually, let me get Let me get kind of a root note. So, why is this being like this now? There we go. Okay. So, let me get a root note here. You probably won't be able to hear this, but that's okay. Oops. Don't use. Dun, dun. Boom. Dun, that's our G. Actually, I'll keep that up because it's helpful. You know what? I will turn this on so y'all can hear it because okay. Bum. Okay. Now we're going to insert these guys. Oh, I'm going to take this whole thing off. I'll just make my life a little bit easier. Okay. And I'm just going to like guess. I'm going to be super arbitrary about this. I had my order messed up before, so I'm just redoing it here. Okay, so and basically I'm just going to stagger them so that each one gets shorter every time. Once again, not doing anything mathematical here. This is purely by eye. These are probably going to get too short. I only want an octave range. I don't like this is gonna. I want this to be chromatic, so I don't want a crazy. I only want one octave difference in notation between the lowest note and the highest note. And what's interesting about this, or what could be interesting about this, is I could maybe play the other side as well. These are going to be way too short, I think. But let's just do it, you know what I'm saying? These last ones are just kind of ridiculous. Okay. This looks cool, doesn't it? I think it looks cool. This material is so nice looking, in my opinion. It just looks like an alien material or something. It's super dark, but then it also has this like sheen to it that I really like. Okay. It doesn't sound good. Wait, maybe. That sounds great. Like, this isn't even close to the microphone. You can hear how loud that is. It's like as loud as my voice. Okay, so the issue we're having now. Same issue as before, but in a slightly different way. Because this is being tightened on two sides, you can see, even though this is such a stiff filament, it's bending, or it's bowing in the middle. So these middle ones end up not being tightened at all. So they're actually rattling. In fact, yeah, you can still move these. So I need some way to tighten these so that it also tightens the middle. And I think one way to do that is actually thicken this piece this way. So add a little bit more material. And then I can also design a slight curve in it. So it's like a caul, like when you're clamping wood together for gluing. You use a slightly curved piece so that when you're putting the pressure on the outsides, it evenly distributes it across all of them. So I think I need to do some redesigning on the actual clamping mechanism, but I think I'm really happy with the sound of this. Which is great, because this was a long print that gave me a bit of trouble. Like, that is crazy. It sounds so good. And what's our note? It is a little bit warped, I'm noticing. That's okay. Kind of want to try the contact mic as well. Okay, let's do it. Let's try the contact mic as well. So just to make this scientific, I'm going to mute my talking mic. In a second here. Okay, muting talkback mic now, and let's hear this. Okay, interesting. Now, I really like the playability of playing it on this side as opposed to this side, because every time I hit this side, my finger makes contact with the chamber. Versus this. makes me want to design this so that I'm playing it on this side now. Oh, this is actually really interesting. So just letting go of the contact mic, getting a kind of a distorted thing because it's just vibrating against the chamber. We can maybe use that. Okay, wait, I'm going to mute the talkback mic again. I like that. Oh, cool. Okay. So, playability wise, though, this is nice because I can hold it, but we can make this work, and I'm probably going to do a tabletop anyways. This is really cool. This is a good discovery. It has a like kind of creepy, like almost like somebody, like a Charlie Brown adult talking or something. Another thing to note too is these notes, they're very close in distance, but I'm basically getting a chromatic scale out of this. So the difference is minimal, the length required. this is. Kind of settles on like a D sharp. Okay, and this is another factor I need to consider. So, oh, my camera is wrong. I changed all my, because I'm using this new phone thing. Okay, so the other thing to note here is that now that I just loosened this, and this has dropped down to a C sharp, so that dropped down a whole tone. But didn't really affect these as much, so that's the other issue with this current tightening system, is that it's applying different tension across here, which is bad for just the general tone, but it's also bad for tuning, because that means as I tighten or lower this, these edge notes get more affected by the tuning than these middle notes. So, I'm gonna need to design basically a better bridge and tuning mechanism for these. Once I do that, once I can get a mechanism that can tune all of these evenly, I think we're golden. Like, I don't see this. The tone is great where it's good. Now it's not good. It sounds so good. It's even better with a pick. Okay. This is really exciting. I'm really happy with the body of this now. This is the body. Oh, it's so cool. Really happy with the body. We gotta come up with a new design for this. So let's jump into our design software. And we'll take a look. What is my hair doing right now? I'm going to unplug this. Get rid of this. After this video, I'm going to do a major shop update because it sucks in here. It's so hard to keep things tidy, and like stuff like keeping my microphone cable off the ground would be amazing. taking my mic cable off the ground would be amazing, or my headphone cable off the ground would be amazing. Maybe that's fine for now. There's so much stuff everywhere, and a lot of it's on the ground. Okay, so this is our issue. So I think first and foremost, I'm just going to hide that for now. I'm going to hide all the tines. I think this piece we should design this so that, let's flatten out that bottom. Boom. And just notice the way I'm flattening this, it's probably not an accurate way, but you can see how this line has all these little steps in it, indicating like it's got like an angle on it, versus these lines which are parallel or perpendicular to the screen. Now these ones are all wiggly and this bottom one's flat. So that's that's designing with vibes. Oh, this one I don't know if I can get this one. 4.1, 3.6. So minus 3.7, 3.8. Oh, yeah, 3.8. Boom. Okay, so those are angled appropriately. I don't even know if this is the right way to do this. You know what I'm even thinking? What if I made it so that the tines get clamped onto this, and then this whole thing is inserted? Oh, but I've already designed the holes. There's nowhere to add extra holes. No, I think it's okay. I think what we're gonna do is this. I'm gonna move this guy up a bit so we get a more aggressive angle. Because I think I would like to play it like a regular kalimba. I would like it, but essentially I want these to be tilting up like pretty significantly. So let's just do it with this by like lifting that up, extruding this down to this level. It's a weird shape, but that's okay. Let's extrude this out a bit. Oops. Nice, okay, that's fine. Okay, so that's a pretty aggressive angle. And now I want to connect these two. Connect to these. So let's just add a little tangle here. Sure, 2 millimeters is fine. And then we can extrude this right into this guy. Join them. Okay, that's one body now. So the reason I'm doing this is because when I was trying to move the individual tines, it would move these individual pieces. And so now when I move the individual tines, this is all one solid piece. And then to add to that structure, let's go like this and project this. Okay. And then let's go here and make this 15. Sure, 15 looks good. 15? Sure, 15 looks good. And then we'll go from this corner, tangent, from this corner, tangent from this corner, tangent from this corner, tangent. Extrude this guy. So now the bridge is going to be locked right into the screws that come through. So that way when I push the individual tines back and forth here to tune them, the bridge doesn't move. Okay. Now the clamp. Oh, the clamp, hey? So this, I want to design a... I think I basically just want to design a curve into this. A slight curve. And maybe to do that, all I have to do is look at this. I'm going to tighten this way down. And you can see the tiniest little curve there. And it's minimal, right? It's very, very subtle. One thing I am going to do is I'm going to make this whole thing bigger. So to do that, let's sketch here. I want to go from there straight up, okay. And then from there straight up, okay. And the reason I'm doing this is this will add rigidity throughout. Can I just delete this? Yes! Sometimes Fusion 360... Oh, shit. Just gets me, and then other times it doesn't. Nice. That's what I love to see. Hone in. Hone in. Ronin. Also, I want to make these holes just slightly bigger. Having these holes a little bit longer too. Minus 0.2. And a little bit bigger will prevent it from locking up like it has been doing. Although now that I've made them bigger, it actually might rack a bit more, so might have just bit myself on the butt. And so now that I've made it thicker, it won't bend as much, which is good, but it's also bad because now I don't know how much I need to adjust this. I'm also going to add a fillet here, just because I know that as I clamp down, this is going to want to bend in this direction. So that will kind of help a little bit with stabils. The stabils. You know what? Just for the hex of it, this is purely design. Just want this to look a little bit nicer, you know? Just want this to look a little bit nicer, you know? Jumba juice. We can go like this. Okay. Oh, I knew there was going to be something like that. That's okay. juice. Boom. Boom. Okay, that looks quite nice. Quite nice indeed. So, and this should all be very printable. How am I gonna add the slightest ever curve to this? I don't know yet. This is kind of like pretty weird. I'm gonna try something. I'm gonna try a 3-point arc. And just give it like the tiniest little curve there, right? Real suts. And turn our sketches back on, and let's try a sweep of this profile and select this path. Ooh. Join. Oh, yeah. Oh, yes, baby. Done. So now we've got a very, very slight curve. That worked out great. Except for this. Now we've got this dumbness. And I can't extrude that because that's okay. I will just do a sketch. Oops. I will just do a sketch and project that and that. Okay, and now we can extrude these back down. Okay. Oh yeah. All right, let's print these bad boys. So I'm gonna go new bridge edge. Let's keep it. I like that. New call clamp. This is also why I often can't find files, because I name them stupid things. It's fun, you know. It's just fun. So, okay. If I open Kalimba, nice. To use this printer for printing, please switch the printer model of project file. Nah. Okay, and I just opened this up so that I could have the same settings. Delete all. And let's throw this bad boy in. Butaceous. And this bad boy in. Butaceous. Move it over. Nice. Look at that. Look at that nice curve. Okay. Sliche. Fine, that looks fine. Looks like we got like 6 layers, which I think is good, right? That's what I had last time. I don't know. It's fine. Obviously, increasing the number of wall layers will make this thicker, but I think that's good. This is a 3-hour and 22-minute print. It's like not that crazy, but it is crazy. Let's do it. You know what I mean? Let's just do it. You know what I mean? Where's the floating cantilever? Show me the floating cantilever. No, I don't see it. I think it thinks that these super minor angles here are floating cantilevers, but it can handle that. It can handle that. I'm not worried about that. Okay, let's print it. Print. SNED. Okay. So while that's going to print now, we can work on something else. I don't want to design the cymbal right now because it's a 3-hour print. And I don't think it's going to take me 3 hours to design a cymbal, and I don't want to stream for that long. So let's try. I'm going to just go grab some wood, and then I'm going to grab some parts for a different instrument, which we've seen already, but I'm going to keep the suspense going here. Give me give me like 30 seconds. Okay, so, let's go to our full screen. Okay, what do we have here? More pipes for the membrane flute. Okay, did a couple things. So, I don't know if you remember or if you've seen it. Basically, I have this membrane flute, and I'm having a real hard time tuning it and making it playable. So I wanted to create a more modular system that will let me fine-tune the whole thing. Oh my god. 1 second. Okay, so the membrane flute, blow into it, and there's like holes and stuff. Adjust this. This drives my cat crazy though, so I don't want to play it too much. But so it has holes that are playable, but the problem is with tuning these guys, the hole placement matters a lot, the hole size matters a lot, the length of the overall instrument matters a lot. So if you have something tuned perfectly, and the more tubes you add, typically the lower the instrument gets to a certain point, and we delved into that in a different video. But basically, I want an instrument that has a mouthpiece like this that generates the vibration, and then I want to be able to put a bunch of different lengths of tubing on it so I can get a different range of notes. So I want to be able to hit bass with this. I want to be able to hit the nice high notes that it's already doing. The problem is the ratio of the distance between these holes is dependent on the length of the overall instrument. So, you know, even if I got this tuned perfectly with this hole length, as soon as I add another section of tube, the ratio doesn't work anymore, so it won't play in tune anymore. So I really don't want to have too many pipes where the holes are predetermined, and I want to be flexible with that. The other thing too is the root note, so with everything open, that's tunable by just doing micro adjustments to the length of the whole instrument. And so what I did do originally is I printed this long sleeve that is supposed to go over the small tubes, which I have like a million of these. And I want to be able to shrink or grow the instrument based on that. So originally I had these, and these were just little connector pieces so I could connect individual pipes like this. And these worked okay. In my design software, the hole on this was the exact same size as the outer diameter of this. And generally in 3D printing, if you want things to fit together, you have to add clearance between parts. But I wanted this to be a tight fit, so I added no clearance, but it's still relatively loose, which is, I think, you know, I think that's a good thing, because that's basically saying the printer's really accurate. All the printers, and I've printed this on multiple, I've printed the different parts on multiple printers, and for some reason it's just, everything's fitting together great, but it's a little too loose. So when I did, and then also these are really short, so, you know, these are designed to connect two pieces together, but they're not really designed to allow me to have much. I mean, I have a little bit of control over the tube length with this, but, you know, the further out I go, the weaker the whole thing is. So, so I printed a long one, and remembering that I wanted it a little bit tighter, I shrunk this inner diameter by like 0.01 millimeter or something, or 0.02 millimeters. And that was too much. Now it's too tight. I can't get these pieces in all the way. They go in a little bit and then they stop. So this was pretty useless. So what I did instead, and we'll see, I haven't tried this out yet, is I printed these at the original size. So these are the exact same diameter, inner and outer. But you'll see on this guy, there's a line right there, and that's called the Z seam. So every time the printer prints a layer, it starts a circle, prints a circle, and then stops, and then starts the next one. Every time it starts and stops, it leaves a little artifact in the print. And so in this, automatically the slicer will put the Z seam along the same path. But there's a setting where you can make it random, and that's what I do with this. And now you can see it's got all these little pimples on it. Doesn't look great, but doesn't matter, because hopefully my thinking was that having these random will give me the tightness I want without being too tight. So let's see. So this is a pipe. Oh. Yeah. This works great. I mean, it's a little loose at the ends, but that's okay. This feels awesome. Yeah. Okay, I'm happy with that. And I printed, how many of these did I print? Like 7 of these. So I've got lots of options now for extending and tuning the flutes. And what I'm kind of hoping to do is, you know, I've got like these that I printed with holes, and I have this one that I drilled my own holes. But what I'm thinking is, with a combination of like these sleeves that can actually be used to cover up holes, I'll be able to really play around with different combinations of tubing and whatnot, and different combinations of sleeves to, you know, all I'm trying to do here is play individual parts of the song in different frequencies. So I don't need a flute that I can play every song in the world on. I just want one that I can play a specific part that I'm thinking of, and I might even discover different parts based on the playability. So being able to kind of adjust where the holes are and how many there are on the fly is exactly what I'm going for. So that's the plan, and so far it's feeling pretty good. Just pulling the brims off of these. Now you're probably wondering what these big discs are, and if you haven't seen my original video, my original 3D printed song video, then you'll have no idea what these are yet. You might be able to guess. But I'll show you in just a second here. Okay. Lots of tubes. Lots of tubes, lots of fun stuff. These are drums. Really simple 3D printed drums, and I really like the way these sound. In the last song, this is one of the instruments that I really didn't have to do much post-processing to make it sound good, and realistically, I think if I just didn't post-process them at all, they would have worked. With just some clever mic placement and stuff like that. And I printed a little clamp. The reason I'm reprinting these, though, is because I gave those drums to my father, who does not live in the same town as me, so I don't have them anymore. So I just printed some new ones. Plus, you know, this will kind of match the color scheme of this video, which is much more monochromatic. Okay, so these sound like this. This tiny one sounds like a little crazy, but the big one sounds awesome. Middle one sounds pretty good. So this is I just reprinted exactly what I had last time. There's just so many cool things you could do with that. But I'm going to print like a bunch of these. I'm going to print some bigger ones. And then, of course, I have all of the pieces that I built for the kick drum video that I can use as percussion. I really want this to be a percussion heavy song because I just think that makes songs cooler for the most part. And these nest as well, which I really like. So yeah, that's that. I want to play with the flutes a little bit now that I've got this kind of going. This is the flute head with a PLA skin. It's very high pitched, really hard to play with. I don't know how much use I'm going to get out of that. So for now, we're going to play around with the one that has the flexible TPU head, which will be much better at getting the low notes we want, and also it can also do high notes. So the range of this one's just great, and it's kind of like, I think it's going to be the main guy here. So sounds crazy. Yeah, so let's just let's see how easy it is. Okay, for example, let's try and hit a G. What is happening here? Oh. So we want to hit a G. So this is too high. that's too low. So let's see how much range I can get out of this. So the other thing too is I've noticed with this instrument, the longer the tube is, the more stable the note is. So as you can hear with this one, just by blowing it, not fingering anything, you get a pretty wide range of notes, which can be cool, but it also makes it really hard to play in tune, and I can't use tuning software on this song, so that is going to make it difficult. Also, we just figured out the lowest or the highest note I can get with this combination of tubes is, which our G is. Wait, no, that's wrong. It was lower, wasn't it? So it's a little, it's a little low, and it's kind of all over the place. So let's go an octave lower, because that doesn't sound good anyways. To me, that sounds bad. I have this super long, curvy tube, which adds a lot of low end. So let's go with this. Let's go with this. Let's go with this, and then this. So when it's that low. So this is what I love about this flexible membrane is when you blow a certain level, you get this. And notice I'm blowing at a bunch of different strengths there, but it's kind of staying at a similar note. I'm talking to the wrong camera. But if you blow hard, you get up into that higher range, and that actually is like super stable. There's very little I can do to change the note without adding tube or whatever. So that's really cool. So what? It's a little low. I'm actually going to go direct into the curve here. See what that sounds like. Cool. We can hit a G now, which is awesome. But this isn't a playable instrument yet. When I mentioned I want to be able to play certain parts, it's literally like I want to be able to kind of hit like a couple notes in a take, because I don't want to just sound like I'm, hitting one note at a time. That'll be very obvious. I want to actually be able to hear, like this kind of thing. So I want to add some holes, and obviously that's going to add length. This is now a really low instrument, which is okay. Let's go for the octave down. Wait, what note is that? What am I getting there? I'm gonna go like this. It's a little loose on this one still. nice. So we're hitting G, and then we're hitting F, which I don't think that's even part of the key. Let me play it. Okay, so. Let's just do some of this here. Let's look this. Oh. Pretty cool. The sound of vibrating is kind of driving me crazy. It sounds good in the room, I guess, but when I recorded this the other day, because I was doing this already, it was sounding like a little. The high end was just too crazy, and it's literally the sound of this little membrane slapping up against that thing. So I'm wondering if. So this makes a big difference. That's actually really interesting. Might experiment with more covers on that. I don't mind a little bit of that high end, but too much is. Oops. Okay, that's not a part I want in the song, anyways. So. What if we tried? Try covering some of these other holes. How cool is that? And we can play around with other stuff too. Like we can go like this, and then I have another one that's got holes on it. Let's go like that. And let's go like that. So now I've got 2 holes. Oh, so cool. Boom, boom, boom. Really cool. Really cool. Let's pull this guy off. I'm loving this. I'm loving this now. This feels like I'll be able to actually come up with parts, and I'll have to build a different instrument for each part, but that's okay. That's the other thing too. If you kind of only sort of cover whole, you can get really cool tones. Like that's like a good synth sound, I think. Oh, so fun. So fun. So I'm going to be playing around with this. I have also the small mouthpiece as well, which sounds totally different. And this is what I love. I love, you know, not just mimicking. With this whole project, I don't really want to, you know, use up all this time and material to print an instrument that has one sound. I love when I can print something where I can change out parts and make it modular and actually totally change the sound. And this has been the best version of that so far, because every little change I make makes a huge difference in the sound for the most part. You know, whereas the kick drum one, if you saw that video, obviously I printed so many things and I tried so many things and they all kind of sounded the same. This one's actually like I'm experiencing total differences. I'm also wondering, like, because this has so much flex to it, I'm wondering. You know, we can do stuff like that. subtle. So I'm gonna play around with that. This is probably good enough for this stream. We're gonna come back when the Kalimba bridge is done printing, and maybe I'll start thinking about how I'm gonna design this new symbol and experiment with that a bit too. So I think that's good for now. Yeah, let's call it there. Looking forward to the next thing we try here. All right, talk to you soon.